Hey there everybody. So today we're going to be looking at this booklet here called the Sine Laws. And I'm going to break it up into two parts. We have the Sine Law and we have the Cosine Law. So today is the first part dealing with the Sine Law. Now these laws, both of them, the sine and the cosine law, both of them individually, can't make up the Sine Laws. Right? Cosine has the word sine, and then sine has the word sine. So plurally, they're called the Sine Laws, but each one individual is the Sine Law and the Cosine Law. So, anyways, these laws are designed to help us deal with triangles that are not 90 degrees. Say, for example, something that looks like this. Right? We don't have any angle here that's 90-degree angle. So, in the past, you would have to draw a line down from the top, make a straight line, and make two 90-degree triangles, one over here and then one over there. So I'll solve this the old-fashioned way so we have the answer, and then I'll go and I'll show you how to use the Sine Laws for this because they're quite interesting. Okay, so I'll sign them up, and you might want to write these down for yourself actually on the top of your sheet somewhere or on a little note so that you have them and you're able to remember them. Okay, so anyways, I'll start off with the old-fashioned solution. Okay, so I drew my little line down here, right? I use, well, that's this angle here, that's opposite, that's hypotenuse, so opposite hypotenuse is sine. So I say the sine of 70 is equal to opposite y over 12, and that's exactly what I've got here. Sine 70 is the opposite y over 12. And I just go times both sides by 12, right? So times 12 to this side cancels out the 12. So 12 times sine 70, that's what 0.94 is, winds up getting you 11.3. So that's this length of the line here, this letter y. So now I'm going to use that value, 11.3, in this triangle over here, to the triangle on the left, to solve for x. So I'll do that one in blue. Okay, so we have that. Okay, so there's my 11.3. There's the angle, so that's opposite over hypotenuse. Hypotenuse is the x, which is on the bottom. So we have to do the little swappy dance there. X and the sine 50 change hands, change places. So x is equal to 11.3 divided by sine 50. Sine 50 is 0.77. And so you calculate that out, you get 14.7. So that's our value for x, right? Boom, up there. 14.7. Okay, and that was part of your job from last day, is being able to be creative about setting up right angle triangles and using that. Now it's a fair bit of work, right? 2 full steps, 2 separate solutions. You have to know how to solve for them, which one to solve first. You have to have a fairly good and creative process in order to manage that. But I want to look at how to deal with this using something called the Sine Law. So I'm going to erase all this. You can scroll back to it if you need to. This is about the 3:30 mark of the video. And if you want to come back to this long method, you can. But let's have a look at the Sine Law, because that's kind of way faster and better. You know how synthetic division was way faster and better? Sine Law is way faster and better too. Let's have a look. Okay, so the Sine Law is written like this. Sine of big A over little a is equal to sine big B over little b, sine big C over little c. And the big letters are your angles. So A, B, and C, those are our big letters. Our little letters are the sides that are opposite the big letter. So if this is angle A, that's little a. So I would write that as little a. If this is big B, then this down here is little b. And if that's big C, then the side over here is little c. And that's how you label your triangles to be able to fit this formula. If they have different letters, you either change the letters on the triangle or you change the letters in your formula. But it basically says the sine of an angle and its opposite side, that ratio, right, one divided by the other, is consistent for the entire triangle, whether you're looking at it from angle A, angle B, or angle C. So the sine divided by its opposite is the same for all 3 angles. That's nice and handy because we can use that very efficiently in a problem like this. So let me set up a T-chart, go nice and slow motion, then you'll be able to see this thing play out quite easy. So it's a formula, right? And you just plug in the values of the formula. You know, sine big A. Well, big A is 70. So sine 70 divided by little a, right? Little a is the opposite side. So an angle and its opposite side. Boom. So there's sine 70 over x. And we don't know anything about angle B, nor do we know anything about little b. So we just write them in anyways. You don't have to write anything if you don't want to. And then sine C, well, we know the angle, so that's sine 50, and we also know its opposite side, which is 12, right? So I've written them in to the formula. Now the next step is something that you really haven't seen yet. It's not a big deal, but let me illustrate it for you. Right, in our formula, sine B over little b is not needed. So we cancel that out. And we wind up with just a simple situation like that. Boom. And so what we have is we have just two parts of an equation. Basically, if there's an extra part that's in there that's not needed or not about anything that we're looking for, we can eliminate it. Right? Everything is equal to all these other things. So we can eliminate the middle parts that we don't need. Sometimes you eliminate this guy. Sometimes you eliminate this guy. In this case, we eliminate the middle guy. But it depends on what you have for your question. So we eliminate it, and let's see what we get. Okay, so now it's a matter of just solving for x. X here is on the bottom of two fractions, so we've got to flip both fractions. We've got to do a little bit of fancy shenanigans, but it's not really that hard. You've done this before. So let's solve for x and see if you can get the answer too. Okay, we have to flip both fractions, get x on top. And now I just times both sides by sine 70, so that part cancels out. So over here I'm going to times by sine 70, see what we get. Okay, x is equal to 14.8. So there you go, right? Almost identical. The reason why it's not quite identical, I think, is probably because we have rounding errors when we're doing the other one. And this one is a lot more accurate because you're keeping the numbers right off of your calculator when you plug those values in. So that's the sine law solving for a missing side. Let's have a look at the sine law solving for a missing angle, how that works. Alright, so here's an example where we only have one angle. And let's say I wanted to solve for angle A over here. Okay, so I'll put a little x in that spot. So I want to find that value. So because this isn't a 90-degree triangle, we don't have any information about using SOHCAHTOA because it's not 90 degrees. So now I have to figure out how to find that value of angle using the sine law. So I have big B, this is little b down here, don't forget. Angle A I don't know, this is little a, and this is little c, and that's big C. So if I think about the information that I have and what I need to find, well, I'm looking for that, and I have that, and I have that, and I have that. So of the pieces of information that I'm needing, I have 3 of the 4 parts. The only part I don't have is that angle. So I'm going to cancel this guy out, and I'm going to plug into that formula right there. So let's see what happens when I plug those in. I get this. I'll shut that off, so I won't make you wait like a minute for me to do it, alright? Okay, so that's what the formula looks like with everything plugged in. Of course, we're not using anything from the C values. So now it's a matter of solving for x. First job, well, I don't need to flip it. X is already on the top, so I just need to multiply the 12 to both sides. Let's see what happens there. I need to do a fixer because the numbers don't work out. I have to make that an angle 50. So, sorry, don't hate me much. Okay, so anyways, I plug those in and I see what I get. So let's see what happens there. Okay, so I get sine x equals 0.92, and then I have to cancel out sine. So to cancel out sine, I have to do inverse sine, right? Your second function. So let's have a look there. Okay, so I get 66.8 degrees, and that that helps us determine our side length. So our angle value right there. So we can use the sine law to solve for missing sides and for missing angles. But in order for it to work, we need to know a full set of either the A's, the B's, or the C's. See, over here we have the B's that we have a full set of. If you don't have a full set of either of these, you can't use the sine law because it doesn't play out. So we have to use the next one on the list, which will be the topic of the next video, which is about the cosine laws. So okay, I'll log off and I'll set up the cosine law video for you. Alright, hold on. Take care.